As scientists, we spend a lot of time experimenting in the lab, and we do a lot of measuring. Measurements represent quantities, the amounts of a substance. There are a lot of different ways of taking measurements. Horses are measured in hands. In ancient times, people used the cubit to measure things. And so the scientific community adopted the International System of Units, or SI. So now we all agree that if we're measuring length, we'll report those units as meters. And if we're measuring temperature, we'd report those units as Kelvin. And now everybody knows what's going on. Density is a property that looks at how massive a substance is compared to how much space it takes up. Let's compare the density of marshmallows to the density of gold. You can see that marshmallows are much less dense than gold is. So what does that mean? Well, if we had equal masses of both marshmallows and gold, let's say 1 gram, our marshmallows would take up about this much space, and our gold would take up, about that much space. We said that density is a property that looks at how massive a substance is compared to how much space it takes up. And the formula for calculating density is density is equal to mass then divided by volume. And if we had equal masses of both the marshmallows and the gold, and density is mass divided by volume, since the volume of the marshmallows is so much greater, it takes up so much more space, then the density of the marshmallows is so much less than the density of the gold. And since the units for mass are grams, and we're dividing by the units for volume, which are centimeters cubed in this case, we end up with the units for density of being grams per centimeter cubed, or grams per cubic centimeter. These are known as derived units. And that's what you get anytime you multiply or divide standard units. It's really important to know how to convert between different units. Conversion factors allow us to do that. For example, we know that 1 tablespoon is equivalent to 3 teaspoons. Let's express that as a ratio. We could say that 1 tablespoon is equivalent to 3 teaspoons that way, or we could say that 3 teaspoons is equivalent to 1 tablespoon. Either way, now that we've written them as ratios, they are conversion factors. Let's say that I'm baking, and the recipe calls for 4 teaspoons of baking powder. But I don't have a teaspoon. All I have is a tablespoon to measure with. I'll start with my given quantity, 4 teaspoons. Then I'm going to multiply it by one of these conversion factors. And since I'm solving for tablespoons, I want to end up with tablespoons in my numerator. And that's the conversion factor that's got tablespoons in the numerator. So when I multiply my given 4 teaspoons by my conversion factor, what ends up happening is that I'm dividing teaspoons by teaspoons, and so they will end up canceling out, and my answer is 1 1/3 tablespoons. There are 5,280 feet in a mile. This is Mount Everest. It's 29,028 feet above sea level. I wonder how many miles that is. We'll start with our given quantity. We'll multiply it by a conversion factor. So I'll take this and write it as a ratio. And since I'm trying to solve for miles, I want that in the numerator. And I need feet to cancel out, so that needs to go in the denominator. And when we multiply, our feet will cancel, and we end up with 5.5 miles. And so what we're actually doing here is using units to solve problems that involve measurements. And the name for that process is dimensional analysis. And it comes in really handy in problem solving in life sometimes, and you'll definitely need it in chemistry. So I hope this helps.